Hello guys, Tom Young here from Coding for Youth. I'm so excited to be with you again today. And today we're going to continue from where we stopped in our last lesson. So we did an introduction to Python, and of course we have checked some few things, and also we talked about how you can install Python on your computer, how you can run it, um, as well as we talked about variables. But today, I just want to, in this particular lesson, I just want to do a little bit of discussion just to encourage you because, of course, this channel is meant to encourage youth and everyone to, to program. I want to encourage you to at least write a bit of code every day. But before we start, I would like to request that you subscribe to this channel and show your support, just to encourage us to continue to bring you tutorials. So today, uh, I'm going to be your instructor. But let's see what we have for today. Today, we're going to talk a little bit on what is a program. Let's start from there. What is a program? So I did a little definition here. Say a program is a sequence of instructions that specifies how to perform a computation. So basically, a program uh, is when you give instruction either to a computer. Basically, we are talking about computer here. So you give instruction to a computer on how to perform a computation. Okay, computation means manipulation of data. Okay, so the computation might be something like mathematical computation, such as solving a system of equations or finding the roots of a polynomial. But it can also be a symbolic computation, such as searching and replacing text in a document, or something graphical like processing an image or playing a video game, or even a video. Okay, so we'll talk about things like inputs in computation. So when you get data from the keyboard, a file, or you open a file, or on a network or some other device. We'll also talk about outputs in computation when you display data. In our previous lesson, we used uh, the print statements, which we use to display data on our command prompts or command line. Okay, you can, output is also when you save a file or you send it over a network. Now, what is maths or mathematics? When you perform basic mathematical operation like addition and multiplication. So today we'll look at how to run Python program. So but before we let's look at how to run a Python program. Of course, we discussed that a Python program can be executed uh, in several places. You can actually start with online. You can actually execute Python program in your browser. Um, there's a good recommendation that I can give, which is Python Anywhere. You can use the free version of Python Anywhere, which is a platform that is being managed and created by Anaconda. Um, you can execute Python, from your browser. We also, when you install Python on your computer, you have the Python IDLE, uh, which is basically, an interpreter where you can use to execute your Python program. So, so as a beginner, you might encounter such challenges, of installing Python on your computer. Um, but if you're familiar with your operating system, or if you're comfortable with your command line interface, you have no trouble installing Python. Okay, but like I said, for beginners, you can use your browser to run Python. Okay, so I have that recommendation, Python Anywhere. which I would like to show you. Um, this is the Python Anywhere console, where you can start writing your Python. You can execute Python. This is my browser and write Python, Python code, from this place. Like for instance, I can do a little bit of mathematical operation, like 5 plus, 6, and then the result is 11. Okay, so you can, test your Python skill, using this browser. So let's go back to what we are discussing today. So before we get to debugging, talked about running Python. So the Python interpreter is a program that reads and executes Python code. Okay, depending on your environment, you might start the interpreter by clicking on the icon or by typing Python on your command line. And when you start, you should see an output like what we said in our first class. You can use your command prompts or your command line that comes with your operating system. Okay, and when you type Python, you see a prompt, a 3 arrow indicating, or you also let me just show you the ID that comes with Python. In this ID, you can see execute Python code. You can see 5 plus 6, and then you see the same thing. We have 11, and of course you can save Python on a file. You can create a new file and you call the file, and of course it will be executed for you. Okay, so those are the ways you can actually run your Python program. Okay, so now let's talk a little bit about um, a little discussion on formal and natural languages. So we have I'm going to define a natural language, or languages are the languages people speak, such as English, Spanish, and French. Meanwhile, formal languages are languages that are designed by people, by human, for specific applications. So programming languages are formal languages that have been designed to express computation. Okay, so natural languages, they are not designed by people, although people may try to impose some order on them. Natural languages, we can say it's evolved, it evolves, it evolves. So meanwhile, however, formal languages, for example, the notation that mathematicians use in formal language, that is particularly good, that is particularly good at denoting relationships among numbers and symbols. We see chemists use a formal language to represent the chemical structure of molecules, and most importantly, okay, so programming languages are formal languages that have been designed to express computations. So formal languages tend to have strict syntax rules that govern the structure of statements. Okay, for example, if you say 3 plus 3, which is equal to 6, is a correct, syntax. Uh, okay, so formal languages, have a strict, syntax that you must follow. Okay, so we have things like although formal and natural languages have many features in common, but we can talk about tokens, structure, and syntax. Okay, so we talk about ambiguity. Natural languages are full of ambiguity, which people deal with by using contextual clues and other information. Formal languages are designed to be nearly or completely unambiguous, which means that any statement has exactly one meaning, regardless of their context. We'll talk about things like redundancy. In order to make up for ambiguity and reduce misunderstandings, natural languages employ lots of redundancies. As a result, they are often verbose. Formal languages are less redundant and more concise. Okay, so we also talk about things like literalness. Natural languages are full of idiom and metaphor. Okay, for instance, if I say the penny dropped, there is probably no penny and nothing dropping. But this is an idiom, which means that someone understood something after a period of confusion. So formal languages mean exactly what they are, what they say, because we all grow up speaking natural languages. It is sometimes hard to adjust to formal languages. So as as you're venturing into the world of programming, just see it as if you're learning a new language. It might take a little bit of time, but then as you keep on learning, keep on practicing, because the best thing, or the best tool or secret to learning programming and to become a best programmer is by practicing. You practice constantly every day. Okay. So just to encourage you, you just have to keep on practicing. I mean, at the beginning it might look somehow tedious and difficult, but the more you practice, the more you get to know, understand the syntax, the semantics, and you know get to be attached to the language. So uh, to encourage you, you just have to keep practicing. So let's talk about things like debugging. Now, programmers make mistakes. You know, for whimsy reasons. Programming errors are called bugs, or program errors are called bugs, and the process of tackling them down is called debugging. So the process of finding errors in your program when you write a program, and then you will see that you're not getting the results. There are a lot of types of debugging. So programming, and especially debugging, sometimes brings out strong emotions. If you are struggling with a difficult bug, you might feel angry, despondent or embarrassed. There's evidence that people naturally respond to computers as if they were people. When they work well, we think of them as teammates, and when they are obstinate or rude, we respond to them the same way we will respond to rude, obstinate people. Okay, so preparing for these reactions might help you deal with them. One approach to think of the computer as an employee with certain strengths, like speed and precision, and particular weakness like lack of empathy and inability to grasp the big picture. So your job is to be a good manager, find ways to take advantage of the strengths and mitigate the weakness, and also find ways to use your emotions to engage with the problem without letting your reactions interfere with your ability to work effectively. So learning to debug can be frustrating, but it is a valuable skill that is useful for many activities beyond programming. So at the end of each of this, you know, we'll see how we can, at the end of the program, every program we write, to see how we can find bugs, and then learn how to debug them. Okay, so we are going to continue with uh, where we stopped yesterday. We talked about variables. Now I want to talk a little bit about expressions and statements before we dive into our Mo editor. So one of the most powerful features of programming languages, or programming language, is the ability to manipulate variables. So a variable, like we said, is a space in the memory of a computer where values are stored. Now that space has to be given a name. That's why we give a name to our variable. But what about things like assignment statements? Well, we can say an assignment statement creates a new variable and gives it a value. Okay, so let's hop into our so we are talking about variables now. So now let's go to our Mo editor. I'm going to open the Mo editor. So I'm going to open the Mo editor so we can start. Open the Mo editor. You see where we stopped yesterday. So we'll talk a little bit about assignment statements. So we say assignment statements create a new variable. Okay, and gives it a value. So for instance, we have actually talked about, we have actually gone far with our variables. We talked about unpacking yesterday. Um, Unpacking is when you assign value to, let's say you have a list, and then the list, you have different items in the list. So assigning a variable name to each of those items is called unpacking. Okay, so we talked about the rules you must follow to give to have a um, a useful variable name in Python. Okay, so variable names can be as long as you like we said yesterday. We talked about the snake case, the camel case, and the past cascade case of giving name to your variable, uh, your variables. But I just want to add today that there are some reserved keywords that you must not use when you're giving names to your variable. So you'll not be frustrated. You'll be thinking about, by giving name to my variable, and then I'm having an error. So I'll just list out um, a few of those reserved keywords in Python. Things like force. You can use force to give as a variable name. Class is also reserved. Um, finally, class is reserved. Finally is also reserved. None, none is reserved. True is also reserved. And is reserved. As is a reserved keyword. Assert is also a reserved. Assert like this is a reserved keyword. Break is also a reserved keyword. So see things like continue is a reserved keyword. Def, a reserved keyword in Python as well. And then del is a reserved keyword. I'll just list a few of them. We also have global, which is also a reserved keyword. Brace. So these are a few of the reserved keywords. There are many, a lot of them. For instance, like return, lambda, y, width, yield, and stuff like that. You don't have to memorize this list actually, but in most development environment, keywords are displayed in a different color. Okay. So now, what about things? What about expressions and statements? We can say an expression is a combination of values, or variables and operators. So a value all by itself is considered an expression, and so is a variable as well. So for instance, what we have before, if you go to your, let's use our IDE, you just type 45. This is an expression, but if you press enter, you have the results. If we have given a value to n, let's say we say n is equal to 20. If we now type n, we have the value of 20 as an expression. Also, if we say n plus 20 is also an expression. Okay, so when you type an expression at the prompt, the interpreter evaluates it, which means that it finds the value of the expression. Okay, so what about a statement? A statement is a unit of code that has an effect, like creating a variable or displaying a value. So when we say n equal to, let's say 30 now, this is actually a statement. Now, if we say print n, we have 30. Okay, so these are the things you need to know about variables, expressions, statements. Okay, so we are going to continue uh, with our variables, and then complete it in the next lesson. So I just want to appreciate you guys for watching. Please leave your comments in the comment section. This is just a little bit deviation from what we have been learning. So just want to explain to you the important things you need to know as you begin your journey of programming. It's quite a very interesting journey. So just want to encourage you to code every day. And then we have a lot of resources online that you can use. We have a lot and lot of community people, helping people. If you search online, Google is one of the best places you can use when you encounter any problem or you are not very sure. Use Google. We have Stack Overflow where you can have help from people, and just register on these platforms, and then you're good to go. So I just want to appreciate you guys for watching. Don't forget to subscribe to the channel. See you in the next lesson. Thank you.